Okay, so in this second part of the story, we're going to talk about the different types of intermolecular forces of attraction. So in the first part, we talked about the difference between the intra and the intermolecular forces of attraction. So the intermolecular forces of attraction, we say that these are the ones that exist between molecules, all right? And they are the ones that determine the physical properties of what? The compounds. Okay. So we gave an example of a water compound. We said you have the intra bonds or intramolecular forces of attraction, like that, the combined bonds. Then you have these now. Okay, you can have these now. Okay, so this one is the intermolecular force of attraction, which is usually the hydrogen bonding under water as a compound. Okay, so basically, I want you to explain all these different types so that you have a greater picture of an understanding between what this all means. Okay, so the first one what we're going to talk about is the ion to ion interaction. So as indicated in the brackets, this one exists between or rather in ionic compounds like sodium chloride. So we know ionic compounds are made up of metals with nanometals. Okay, so in such compounds, that's where we find the ion to ion what interaction. So what tells you that you have sodium chloride interacting with another sodium chloride molecule like that. Okay, so these are the ones we are calling as the ion to ion what interaction. But when you talk about sodium and chloride, the intermolecular force there that is in existence within that molecule sodium chloride is what is an ionic what bond. Okay, so an ionic bond is an intramolecular force. Then intermolecular force between the sodium chloride molecules is what we are calling the ion to ion what force of attraction. Okay. The second one is the dipole to dipole. The dipole to dipole intermolecular force of attraction. So what is it about? So this one involves partially positive. So involves partially positive and what? And partially negative molecules interacting with the others. Okay. So for example, when you talk about hydrogen chloride, right? When you talk about hydrogen chloride, so you know that the hydrogen is partially positive, okay, it's partially positive, then the chloride is partially negative in that molecule. Okay, so what is going to happen is that is the molecule, and within itself, the bond that exists between hydrogen and the chloride is obviously going to be what? It's going to be an ionic bond. Okay, so now there is going to be that bond there, an intermolecular bond with another hydrogen chloride what molecule, which is partially positive there, and that one is partially negative. So these ones, the partially negative ones being joined to the partially positive one, that is a dipole to dipole what? Dipole to dipole force of attraction, or an intermolecular force we are calling dipole to dipole. Okay. Then it is not always the case that when it is partially charged, when the partial charges are involved, it's always going to be dipole to dipole. No, there is another form which we call hydrogen bonding. So hydrogen bonding is actually special. It's actually special because it talks about specific atoms being involved in such a bond. Okay. All right. So this one usually, from the name itself, it involves hydrogen. All right. So hydrogen forming a bond with either oxygen, nitrogen, and fluorine. So these are the common types of hydrogen bonding that you're going to have. Okay. So they involve the partially positively charged hydrogen being connected to the partially negative what? Atoms like oxygen, nitrogen, and fluorine. All right. So basically, this one is kind of strong. one of the strongest intermolecular what? Intermolecular forces of attraction. So it exists, it's actually the intermolecular force of attraction that exists in what? In water. Okay, so the fact that it is stronger explains why water has got a high boiling point, okay, and it has got higher heat of vaporization, higher heat of what? Even the melting point is higher because of the same. Why is it higher? It's because the hydrogen bonding, for them to be broken. So remember, I drew something like you have H2O there, okay? So you have a bond like that, right? So these are strong. That hydrogen bond there between the two different water molecules is very strong. So don't never be mistaken when it is the point within a molecule, the bond between the hydrogen and the oxygen. That one is a covalent bond. Okay, don't be mistaken. It's a covalent bond. That one. So the intermolecular force is actually, or in other terms, the hydrogen bonding exists between the hydrogen of a different water molecule connected to another oxygen of a different water molecule, or oxygen from one water molecule being connected to the other hydrogen atom from the different water molecule. Okay, so hydrogen bonding is an intermolecular force of attraction. Okay, so remember, like I said from first video, I say that the intermolecular forces of attraction, they are the ones that determine the physical properties of what? Of compounds. Okay, finally, let's try to talk about the random dispersion forces. So these are also called van der Waals, right? So these are also called van der Waals forces. Okay, so these ones are common in all compounds, all right? Between all the molecules, the random dispersion forces are there, and they are actually the weakest. Okay, they are the weakest. Okay, so between all the types of compounds, so the molecules that you know, they are going more of electrons in short. So the more electrons you have, the more what? The more the random dispersion forces are going to be there. So basically, when you're given maybe examples of when you're given two different compounds that don't have hydrogen, dipole, and ion, then they ask you to determine which one has got stronger intermolecular forces of attraction. Look at the number of electrons. So that explains why actually bromine has got a stronger intermolecular force of attraction in comparison to chlorine. It's because it has got more electrons compared to chlorine. Okay. So basically, these are the types of intermolecular forces of attraction that you need to know. Okay, very important. The ion to ion that exists in ionic compounds, the dipole to dipole moment intermolecular force that exists between partially positively charged atoms and partially positively charged atoms. Then the hydrogen bonding, that is a special type of a bond that will exist between an hydrogen atom with either oxygen, nitrogen, and fluorine. Then lastly, the LDF, which are also known as the van der Waals. These are actually universal and they are the weakest. Okay, so basically, I hope this video gave you the basics about the intermolecular forces of attraction that you need to know. Then the intramolecular forces of attraction, where I talked about under chemical bonding, where it talks about covalent bonding, which can involve polar or non-polar. Polar is a type where you have equal sharing of electrons between the atoms involved in a bond. Then for non-polar, for non-polar there's equal. Then for polar there is an equal sharing of electrons. Okay. So basically we can end here. Then I'll see you in the next tutorial where I'm going to now introduce phase equilibrium. Gets to talk about the phase diagrams of water and other molecules of interest.